Cool. I think most of the waiting room has joined us. I know a few folks might trickle in a little bit late, but thanks all for joining our California Water Data Consortium May Data for Lunch entitled Sharing Data for Drought Resiliency. We have Ashley Vizick with FlowWest here and a few students from the Master's in Environmental Data Science program at UC Santa Barbara's Bren School. I am Hannah Ake. I'm a senior program manager at the California Water Data Consortium, and I'm going to be helping to moderate this Data for Lunch. So a little bit of housekeeping before we dive into the presentations. This meeting is currently being recorded, and it will be sent out via email and posted on our website and YouTube channel after the presentation. We do encourage questions, so please provide your questions throughout the presentation in the chat box on Zoom, and we'll get to them at the end of both presentations. And then as you exit the Zoom, you're going to see a survey at the end of the event. And so please fill out the survey if you have time. This helps us plan for our next Data for Lunch and make sure that you all are interested in the offerings that we share with you. So today's agenda, we are going to have two presentations today. So please feel free to pop your questions in the chat related to each of those presentations. Again, we're going to be holding them until the end of the presentation. One is from FlowWest, and then one is about the capstone project that we've been embarking on with UCSB's Bren students. And so they're going to share a bit more about that. And then we'll have a Q&A at the end. Just a little bit about the California Water Data Consortium for some of you who might be new here. We're an independent nonprofit organization created by a partnership of state agencies and others to ensure that California has access to the best possible water and ecological data. And we really believe that this helps to ensure that everyone living and working in California can prosper in the face of unprecedented climate challenges. So we do this by bringing together diverse partners, including water managers, state agencies, researchers, industries, community organizations, to improve how water and ecological data are collected and shared across the state. So you can learn more about going to our website. I'll drop that in the chat in a bit. And then a little bit more about our Data for Lunch series. That's kind of one way that we fulfill our mission. And so we provide a forum to learn about cutting edge water research and technologies, share insights about water management and challenges and solutions, connect water professionals with each other across different sectors, and then better explore how we can lead to decisions for California's water future. And so I'll drop another link in the chat, or Amanda might get to it before me, on our Data for Lunch series. So I do want to send a quick thank you to our sponsor for this Data for Lunch. The Department of Water Resources and FlowWest have made this particular Data for Lunch possible. And so, of course, if your organization is interested in sponsor a Data for Lunch, please let us know and you can reach out to us. I think we have a flyer that will also drop in the chat. And quick plug for the next one is coming up on June 17th. So please stay tuned. We'll be emailing out more information on that. And so without further ado, I'd like to welcome you to our Data for Lunch today and to our presenters today. So we have Ashley Vizick, who's a principal data scientist at FlowWest, and we're going to have the students from the Master's in Environmental Data Science program at the Bren School at UC Santa Barbara presenting on their work here today. The consortium's been working closely with both of these folks and the state to publish data sets related to drought data in California. And so we're really excited to hear from them about kind of how this work started. You will hear more about that from Ashley's presentation, and then kind of what we're doing next with it and kind of where we hope to go from the UCSB Bren students. So you can learn more about their work and their bios on our website. There's a link that we'll share. But I think without further ado, I will hand it over to Ashley, and I'll stop sharing.
Great, thanks, Hannah. I'm going to share my screen. And give me 1 second. It's going. Okay, so hopefully you can see my screen okay. Great. So like Hannah said, my name is Ashley Vizek. I'm a data scientist at FlowWest, and I've been working with the consortium on this urban water data project for about the last 3 years off and on. And I do other work with salmon data and water data throughout the state of California. So today I'm going to talk about some of the work we did with the consortium, Department of Water Resources, State Water Board, to make data useful for understanding drought, and some of the background on how we got here. Oops. So before I begin, though, I do want to acknowledge that I'm up here speaking, but this is really a huge collaborative effort. When we first got this work started, we did a number of interviews with urban water suppliers throughout the state. We've been working with the consortium, like I said, and most recently, a working group of state representatives. So I really want to acknowledge that this is not just my work. Okay, so the consortium convened a working group of representatives from DWR and the State Water Board to make data more useful. In some cases, that meant publishing data because they were not previously available. In other cases, that meant restructuring data so that it was more usable. And in both cases, that meant developing good metadata to make data more useful. Through this project, we published 5 data sets on the open data portal related to drought, and I'll dive into the details at the end of my presentation. But I really just wanted to set us up of this is the end product of what I'll be talking about, but really the starting place for the work that the Bren team is going to talk us through. So, but before we dive into the details of that, I wanted to talk about how we got here and provide some of the background for this work. So urban water suppliers, which I'm sure many of you know, in the state of California have a number of reporting requirements. Some of those reporting requirements include urban water management plans, water loss audits, water supply and demand assessments collected by DWR. Whereas the State Water Board requires reporting through the electronic annual report, drought and conservation reporting, and most recently, the water use objective. So this information is really important for understanding how water is being used and for monitoring water shortage vulnerabilities that can aid in decision making. So I'm not going to go into all the details of these reports. It's a lot of information. But if you're interested, I'm sure some of you probably know all of the details. But if you're interested, the consortium does have a number of resources on their website to synthesize some of this information. The main message here, I'm sure you can't read all the text on this slide. The main message is really that there's a lot of information being collected about urban water in the state of California. There's a lot of work being done on the topic of urban water data, but some of the background on the work that the consortium's doing and the work that I've been involved in, I kind of just wanted to work us through that timeline. So between 2020 and 2022, a lot of the work really focused on defining the problem and creating a shared understanding of what are the challenges with urban water data reporting. And in June 2022, the consortium hosted a workshop to develop shared understanding on this problem and to start working towards solutions. And between 2022 and 2023, some initial work began on these solutions. And these are big challenges, and I'll get into what the challenges are. And it was hard to make a lot of progress. And most recently in 2024, we decided to focus on the data publication phase of the life cycle. So let's briefly revisit some of the challenges that came out of this initial work on urban water data. And these challenges were identified through reviewing urban water data reporting requirements, doing interviews with urban water suppliers, and also through the analysis of some of the available supply and demand data. And through this, we identified some key barriers to high quality data. When we initially began this work in 2022, we thought about data challenges in terms of from whose perspective are these challenges? Some of the challenges are for urban water suppliers, both large and small, retailers and wholesalers. And there's also challenges for state agencies, as well as data users like NGOs, researchers, and the public. And these are really broad categories. There's a lot more nuanced groups of individuals that are experiencing challenges. But I think this just sets us up a little bit to understand some of the challenges I'll talk through. So one of the first challenges is the way that we talk about water. Different agencies have different definitions for similar concepts. So if you're looking at a data field, it might have a very similar name, but when you dive into the details of what it actually means, you might find out that there is a different definition. So a condominium complex, for example, may be considered a commercial water category by some state agencies, whereas maybe internally, an urban water supplier might consider that a residential category. So this challenge is really just pointing out some of the inconsistencies in the way that agencies are thinking about data and defining data. We also recognize that there may also be a temporal misalignment in the data that are being collected. So internal workflows within urban water suppliers will determine when data are final, which may not necessarily align with reporting deadlines. And you can see in this quote on the slide that sometimes when data are posted for a deadline, they may not necessarily be final due to, in this case, reading of meters. So again, just recognizing sort of misalignment or disconnections between reporting requirements and internal workflows. At a high level, regulatory requirements create challenges for both state employees and urban water suppliers. As this quote says, the legislature continues to divide work between DWR and the State Water Board, making it difficult to access information across agencies, especially in the time frame needed. The next challenge I wanted to talk through is that these challenges really highlight institutional silos that may be at play. Urban water data are self-reported, so each urban water supplier is collecting, managing their data independently. And we talked about how they all have their own definitions, even their own methods for collecting information. And on top of that, DWR and the State Water Board, and even the programs within these agencies operate independently with different missions they are working towards, and they store and manage their data independently. So the challenges I've talked through so far are really focused on the data collection, data entry, and even data planning phase of the data lifecycle. And these are really big challenges to address. They can take years or sometimes decades to work through some of these challenges, especially when we're talking about regulatory requirements. So in the interim, as we continue to chip away at these barriers, we wanted to work on shorter term goals that could help us work towards these longer term goals. And so instead of focusing on these early phases of the data lifecycle, or maybe in addition to focusing on these earlier phases of the data lifecycle, we decided to shift some of our attention to the data publication phase. Some, but not all, of the urban water data being collected are publicly available, though a lot of these data are pretty difficult to use. And by focusing on the data publication phase of the data lifecycle, this helps us address some of these data usability challenges. And these data usability challenges were identified in our initial work, identifying some of the challenges to urban water data. Making data not only accessible, but also usable helps us in a number of ways. So it allows us to track and catalog information that we do have. So it's easier to identify redundancies. It's easier to start to understand some of the inconsistencies and definitions. Working on data usability also helps us develop robust metadata. And what I mean by that is creating data dictionaries, really defining each of your data fields, better understanding methods of how data are collected and how they're reported. And this can often expose, again, inconsistencies or maybe lack of clarity in data reporting. And then when data are usable, more people are able to utilize the information, leading to improvements in data quality. So this leads me to our most recent work to make urban water data useful. I mentioned that in 2024, the consortium convened a working group with representatives from DWR and the State Water Board. It took us a little bit of time to get organized and aligned on what we were working towards and what our mission was. But ultimately, we decided that our goal was to make urban water data that is well documented, findable, accessible, interoperable, and that can be used and reused across programs or other applications. And so that essentially means that data are fair. And if you haven't heard of FAIR before, it stands for findable, accessible, interoperable, and reusable, and is a grounding principle in open data. So working towards this goal required us to make data and metadata fair, as well as to identify relationships and connections between disparate data sources. But this also required work in data governance. It brought up a lot of questions about roles and responsibilities. So once you're talking about connecting data across agencies, it brings up these questions of whose role is it to maintain lookups or crosswalks that make it possible to connect data? And then what does maintain even entail? Um, and it also brought up questions about should there be data standards across agencies for naming conventions or data formats and data structure, and even metadata, data quality, and data publications. So if we think about all of the urban water data that the state collects, this is a lot of work. So to start, we identified 2 use cases or pilots to focus on, and this allowed us to make progress towards this goal and establish a template workflow that could then be applied beyond these use cases. Today, we'll be focusing on the drought use case, though I do want to acknowledge that this state working group that I've been talking about has also done a ton of work to publish and make data usable for water conservation, primarily related to the water use objective. The water use objective reporting requirement requires a lot of data that the state already collects in some cases, and a lot of great work was done to make those data accessible as well through this project. So when the working group was first getting started, Julie Ekstrom, and hopefully she doesn't mind me calling her out, but brought up the concept that data collected through urban water reporting could be used to inform drought management. Though as it currently existed, those data were difficult to access or difficult to use. And so this connected to work that Julie and many others are doing through the DRIP Collaborative, and it presented a really important use case for the state of California. So through conversations with Julie and the larger state working group, we discussed and identified, so what are these data that we would want to make available for understanding drought? We identified 5 data sets that could be helpful for understanding drought. 2 of these are looking into the future, their forecasts about water storage. One of them is understanding actual water shortage levels. And then we had 2 additional data sets to provide some context to this information. So historical data on production and delivery is helpful in understanding how water is being used and how it is sourced. And we also included a data set that includes the latitude and longitude of drinking water facilities. There's, of course, a lot of other data that can be used to understand drought, but this was a starting point for us. And additionally, we called out some data sets that are already published that would be important to this use case. And the idea here is really to start to tell a story from historical to kind of current and looking into the future about what a urban water supplier's water shortage might look like. So these data come from different places. Water shortage data forecasts for the next dry year at monthly time steps are available from the annual water supply and demand assessment. And again, these data are not actual measured data, they're forecasts or projections for a dry year. Water shortage data for the next 5 years are available from the Urban Water Management Plan. And both of these data sets are collected by DWR and available on DWR's WUI portal, as well as the urban water management plans are on the open data portal. The actual water shortage level data set is collected through drought reporting by the State Water Board, though previously through monthly conservation reports. And this historical supply and demand data are collected by the State Water Board. And previously through the EAR. The location of drinking water facilities is collected through CIDWIS and is stored in the State Water Board's Safer Clearinghouse database. So the best practice to publish data is usually to publish a pretty raw form of the data, and that's typically how I would approach a data publication because it allows you to meet a broad set of use cases. But some data publications are not that straightforward. If you have data that are stored in a really large state database, how do you publish all that information? Publishing an entire database is really hard. So we had to make some decisions about how to actually go about this data publication. And one of the main goals of this effort was really to start to piece together these disparate data sources that existed in different places and to begin to make them usable together. And so we started to approach this data maybe a little differently than you might typically by identifying relevant fields from each of these reporting requirements that would help meet our goals for this use case. And so instead of publishing an entire data set in its rawest form, we did some processing to try to fit these data pieces together. And so like I mentioned, in order to actually bring these data together and make it usable, there was some data processing that was applied. And the goal here was to make all of that processing transparent and reproducible. So all of it is being done through our code, and it's available publicly on a GitHub repository so that if you had questions about, well, how did you transform these data and publish them, that would be available for you on GitHub. And another important piece to making data usable is having good metadata so that data users understand how data were collected and what that data field means. And so this data publication also contains data dictionaries for all of the data sets, as well as a data management plan to document where the data are coming from, how they were processed, and how this package could be maintained into the future. And that data management plan is in this GitHub repository as well. So this data package is an effort to make data usable, break down some of the silos that make that work challenging, and really to provide a foundation for expanding this work beyond this use case. I also wanted to speak about how I mentioned a lot of challenges to this work at the start of this presentation, but I also want to acknowledge and celebrate all of the good work that state agencies, urban water suppliers are doing despite these challenges. The challenges that I mentioned are really big. It's hard to create and make data usable. Even when we're thinking about data our health data or financial data, it often is clunky and hard to use. So it's not just urban water data. It's a really big challenge, and it's not something that one agency can fix alone. It's something that we have to do together. So after publishing this data set, we knew that there was still a lot of work to be done. We needed to test the usability of these data in order to improve the data publication and make sure that it actually was usable. But we also needed to start addressing some of the other challenges that occur earlier in the data lifecycle. And we decided this would be a great opportunity to work with the Bren School. Our proposal was accepted, and we've been fortunate enough to work with an excellent team of students from the Bren School Masters in Environmental Data Science. So at this point, I think I'll hand it off to the Bren team, but thanks for listening, and I dropped my email address there in case any questions come up. Feel free to reach out.
Great, thanks so much, Ashley. I think Emma's going to share her screen now.
So we are the Data for Drought Resiliency team. We're all Master of Environmental Data Science students at UCSB, and we're doing this capstone project as part of, or we're doing this project as part of a capstone within our program, which is all about working with small teams to work with clients and develop real-world solutions to real-world problems using data science. Okay, so when we first started this project, we were looking at how we could make everything really helpful to water managers specifically. So we performed interviews, and we had big discussions about what questions we're hoping to answer with this project. So we came up with things like what methods or criteria are used to assess the capacity of conservation, or how do you identify trends in shortages, etc. But when we took a deeper dive into the data, we realized that a lot of what we wanted to answer wasn't actually possible to answer with the data that we did have. So we kind of had to regroup, look at the data, and then think about, okay, with the data that we do have, what can we still answer that would be helpful to water managers? So we came up with questions such as, how have shortage levels changed over time? What areas of California are at risk? What percent of water was delivered to each sector, etc. So once we came up with those questions, we could form our two main objectives. So the entire project as a whole is working towards making this data as usable as possible. And to do that, we created a gap analysis and a dashboard. So the gap analysis is all about identifying gaps in the data that prevent its full usability, and then also identifying potential data that could possibly be included to these data sets that would answer more water management questions that we were talking about in the previous slide. And this gap analysis is text, but it also includes code that checks for gaps in the data and provides coding solutions wherever applicable. And then our second objective is the dashboard. So this is all about enabling water resource managers and other stakeholders to easily visualize and navigate the data. So right now, the data is all in CSV format. So you would have to have coding or Excel experience to be able to look at the data, and there's no easy way to visualize it. So on this dashboard, we created maps, graphs, summary statistics, and missing values that are all very clearly shown, and make it as easy as possible for water managers and other stakeholders to navigate the data and to answer their questions. So Ashley already talked about this a little bit, but let's just talk some more about what our data actually is. So we have two categories of data. Our first is actual data. So this is based on actual measurements. Our first data set is reported monthly shortage levels. These are shortage levels from 0 to 6, and they're based on shortage percentages, 0 being 0% shortage, 1 being 10% shortage, etc. And then we have the historical production and delivery data set, which is all about water use and supply in acre feet. And it's our biggest data set by far, with a timeline of 2013 to 2022. Then our second category is forecasted data. So we have the monthly surplus and shortage forecast and the 5-year outlook water surplus and shortage. So it's important to note that out of all of our data sets, 2 out of the 4, so half, are forecasted data, so they're not based on actual measurements. And the monthly shortage levels, although they're based on actual measurements, are not standardized across water districts in terms of how they're measured in percentages. So the only data set that we have that is actual metrics and measurements is the historical production and delivery data. So speaking of the data, talk about some more challenges that we've seen throughout the data sets. So some challenges here are in the organization of the data itself. So the org IDs, which are the main identifier of water districts, are not consistently present in the data. If we look at the table here, you'll see org ID 13 is present in only 3 out of the 4 data sets. Org ID 22 is only present in 2 out of the 4 data sets. This means that if you are interested in either of these org IDs, you are not able to look at information about them in every single data set. Another organizational challenge is naming conventions of water companies and districts that are inconsistent throughout data sets, even within one data set. This example here is all from the historical production and delivery data set, and it's different versions of how Golden State Water Company is represented. So we have GSWC, Golden State Water Co., and Golden State WC. All of this makes it difficult to analyze and code this data to be as usable as possible.
Nice. Now let's talk about another example. Here you can see a graph from our historical data for one of the agencies in our data set. This chart is showing the total produced and delivered water for the given agency between 2013 and 2020. From this graph, I want you to notice that towards the end of 2016 and at the beginning of 2018, we can notice peaks where delivered water exceeds production. Other similar anomalies are sprinkled throughout our data set, and it's important to be able to visualize them for the sake of understanding the underlying trends. Now, let's talk about some of the challenges we've seen outside the data. As we discussed earlier, the data that we have access to is nested into a few CSV files online, and unless you have the skills to do so yourself, there's no easy way for water managers to be able to visualize it. It's important to note that all of this data is self-reported by water agencies, which without any sort of reference would be difficult to interpret some of their metrics. An example of this is our qualitative self-reported data from our actual shortage data set, where the state shortage level indicator values that we have had access to were more recently standardized back in 2022 from short form qualitative survey into a small range of values between 0 and 6, 0 being no shortage and 6 being greater than 50% shortage. Because of this, some of the data was lost in translation as seen on the tables to the right. Moving on, we've discussed challenges, and one of our project deliverables is a gap analysis. We've defined it as the process of identifying discrepancies in the data set and what data is required to answer the question effectively. We are planning on breaking down this analysis into 2 parts. The first being our current data gap analysis, where we will be documenting the issues within our code, such as those naming conventions we talked about, as well as creating scripts to make sure any future additions to our data are seamlessly incorporated. Second, we have our desired data gap analysis, which will consist of answering the questions from our initial proposal and the data required to perform those analyses alongside any other relevant improvements we find along the way. Now, let's take a look at this diagram, which will show the generalized structure of our deliverables for you all to follow along. Here, we can see that most all of our work stems from cleaning and preparing our data to both document issues, organize structure, as well as prep our data for our dashboard tools and visualizations. Our dashboard is going to allow users to be able to select their district or organization and be able to view the metrics across all the data sets we have. Our dashboard will filter your selection and provide you time series and spatial visualizations of statistics such as shortage or surplus, while providing the summary statistics on those values as well. I'll pass it off to Tom to share more information about our dashboard.
Thanks, Takeen. So we have a couple of demonstrations for everyone about our dashboard, but before we get into that, just a quick overview of the different panels here. We have our plot output on the top left one. We have the map of all the California water districts on our right. And then like Takeem was saying, we have our summary statistics on the bottom left. And then if there's any missing information within our values, it will be plotted on the bottom right. So now we're going to move into a scenario. There we go. So in this scenario, we have Maria. She's a state water manager, and she is interested in understanding the trends in water distribution in Ventura County from 2019 to 2022 to understand if there were any effects of COVID-19. Right. So here we have a video demonstration. I'm just going to be talking over it. All right, so like we just saw, this is our dashboard output. This is what you'll see when you first load it up. We're interested in Ventura County within this demonstration. So we're first going to go ahead and zoom in on the Ventura County region. We have all the different water districts for this area. Camarillo right there, city of Santa Paula. So let's take a look at the city of Camarillo. So we're just going to go ahead and populate it in our search bar right here. And then we're interested in the historical water production and delivery, which is already pre-populated, but we can also choose between the 4 other main data sets that we have. But for this scenario, we're going to use that one. And then since we're interested in data from COVID, we're going to do 2019 to 2022 as our date selection. And then we have different delivered types, different produced types, several for each category, but we're going to focus on the total for both, considering this is going to be a shorter demonstration, and we're going to get a plot output right here. So we have total produced and delivered, totals in black with delivered in the solid line, produced in the dashed line, and then date and quantity in acre feet for our axes. As you can see, we have updated summary statistics as well for this date range with total produced at the bottom and then total delivered as well. And as we can see, we have a parallel trends in both our delivered and produced with increasing and then also decreasing effects within in parallel with one another. So one thing we might be thinking is that, is this just related to COVID-19, or can we see this kind of trend throughout the rest of our data? So we can go back to the start of it at 2013 to see if it is related. And as we can see, there is a similar trend between delivered and produced, and it's not just specific to COVID-19 time range. Also too, at the very bottom right are summary statistics updates with the newly calculated produced and delivered. But since we're interested in comparing data between water districts for COVID-19, we're going to go back to 2019 and then switch it up to a different water district. So we're going to select the city of Santa Paula since it's nearby and check out their distribution of data. So likewise, we have total produced and delivered, and it's going to repopulate the graph. And as we can see, we have a similar parallel trends between delivered and produced, but we do have some unusual area where the delivered is more than the total produced. So this would have cause for further investigation.
All right, so I'm going to walk you through the second hypothetical scenario. Here we have Ryan from the Goleta Water District. And Ryan is interested in understanding the trends in water production in his region and how the water sources proportions have changed over time. So let's take a closer look at what he was able to find. All right, so Ryan starts by selecting their own water district, either from the dropdown or directly on the map. Next, he filters by production type. Here he selected recycled water, surface water, and groundwater. In the graph, we can see how these sources change over time. In 2016, surface water and groundwater were used fairly equal proportions, but in 2021, we see a noticeable shift. We can see that cities rely much more on the surface water than groundwater. Now, let's go to the bottom right panel where the missing information is shown. All right, so yes, missing data is more than just an inconvenience. It's often a sign of inconsistency or improper data submission methods. And that's something we encountered during this project. We believe that by clearly highlighting this on the dashboard, where and how much data is missing, users will be able to see where the gaps exist, so it can be factored into the analysis. We're hoping that this addition will create a strong incentive to improve data reporting practices. So these numbers, so that 20% is calculated based on the selected time range, data type, and the water district. It is basically finding the missing values within that frame selected and divided by the total number of rows. So I'm going to quickly show you an example on how to use it by looking at the cities of California's data. All right, so this graph shows the time series of recycled water. We see that it has 0% missing data. When we start adding more data types, so let's add agriculture and industrial delivery, and let's also remove the recycled water so we can visualize it better. So we can see there's a big gap of missing data in 2014. And when we check the calculated percentages, we find that 20% of that data is missing, and that is from 2013 to 2022. So I do want to mention that this dashboard is still a work in progress. We definitely want to improve certain areas and add more features, such as adding a button where reporting documentation can be uploaded. It would also be nice to have a download button so users can have access to the data and the graphs. We also want to add a home page so it's easier to reference the information about the data. And our final step would be to test it and to deploy the dashboard so it's public. Right, next slide. All right, so as we wrap up, I'd like to share a few takeaways from our work on this project. Real world data is messy, and one of our biggest lessons we learn is that real world data is often incomplete and inconsistent. And I'm sure the water sector is not the only one that is experiencing this. While it was challenging, it also gave us a deeper understanding of the barriers that exist in drought management. Through our gap analysis, we have identified areas where these data sets can be improved, and we'll be providing recommendations to address those gaps moving forward. Another key takeaway is that usable data equals actionable insights. As a team, we work together to transform the data into an interactive, user-friendly dashboard. The goal was to make this data accessible to decision makers who perhaps don't have the time or the coding skills. This makes it easier for them to explore and interpret water information. We're collaborating with an incredible team to lay the foundation. This project is a prime example of how working together can drive real progress and help advance data transparency, which is essential for tackling big challenges like drought management. The last point here is that we hope that these tools we've developed, along with the documentation, will help future improvements in California's water data. All right, well, thank you so much for listening. And if you have any questions or comments, please feel free to reach out to us via email. We are a team of master students and we'll be graduating in a month from our data science program. So we'd be happy to hear about your projects and discuss any potential opportunities. Thank you so much. And I'm going to pass it back to you, Hannah.
Great. Thank you all so much. That was a great presentation. Yeah, and already getting some questions about publishing the tool boards dashboard. So no, it's going to be super useful for folks. Yeah, shout outs to Bren and everything and getting some tips on dashboard design. So really appreciate that as we're still kind of finalizing everything. If you have any questions, please feel free to put them in the chat, and Amanda, I might ask for your help in making sure I include any I missed. But going back to the top, I think one of the first questions we got from the chat was, did this working group or the state working group, urban water data working group, have any recommendations for improving data governance at the state level? And I know Ashley talked a little bit about kind of best practices for publishing. And so maybe I'll turn it over to her in a second to talk about if there were any additional recommendations. But I think, Stu, to be direct, that was kind of part of our vision for working with the Bren students is, what takeaways in actually working with this data and these data sets could they identify for us, skill sets, tools, gaps, things like that, so that the consortium can go back and make kind of clear recommendations to the state about how to best potentially describe roles, trainings, tools needed to help publish data like this more frequently and well described. So that was kind of one of the goals. But Ashley, is there anything I'm missing there?
I think that's great. And I don't think we have any formal recommendations from the group yet, but I think lots of lessons
Yeah,
learned.
yeah. Another question was curious to know if remote sensing was part of this data. And Ashley, I'm not sure if you know that off the top of your head.
I don't think so.
Yeah, these were from urban water suppliers, so not necessarily part of this. One question was about unaccounted for water in urban systems. And so was wondering how these data deal with kind of unaccounted for water, if you remember that, Ashley. And some of these questions too, if we're not able to answer them now, we're happy to go back to kind of our state partners and others working with these data who are a bit more familiar than us, and we can help get them answered. But
yeah, I think I would track to a more expert. We didn't include any of the data coming out of the water loss audit in these reports, and maybe that's something that gets at the unaccounted for water.
got it. This one is maybe for the students. Did you use any LLMs or other AI tools to help build out the dashboards?
I would say, to assist us for sure. I mean, I think that it can be useful for coding, especially if you get really stuck to use ChatGPT. But most of what we did was all our own, and ChatGPT isn't quite smart enough to be able to use the data the way we wanted it to.
Great. Go ahead, Tom, sorry.
Yeah, I was gonna say kind of to go off of that, you're doing in terms of you can't just like give ChatGPT like some type of generic out like to get like the or generic question or whatever to get like a good output. So a lot of it is like the knowledge from what we've learned through our program.
Great. And then this is a question about the open data license for the data. Curious if you know about that, Ashley.
Yeah, we actually did not specify a license when we published it to the CNRA Open Data Portal, but I think that's a great question, and we should discuss that. Adding a license. Typically, when I've published packages, we usually do it through a Creative Commons Zero license or CC BY, which is basically like free, open to use, but attribution to the data creator. So I would imagine something similar to that.
Cool. And then one of the questions was kind of about quality assurance and quality control of the reported data being shown in the dashboard. And Ashley spoke a little bit to this, and I'll let her answer in more detail, but that was basically a substantial portion of the work that Ashley did with us at the front end before we handed it over to the Bren students to kind of make sure that it was well described, well documented, that we filled as many gaps as possible early on. But Ashley, I'm not sure if there's anything else you want to say there.
Yeah, I'll just add on that there wasn't by quality control, like identifying outliers or flagging data that it seems like an error or a typo. The historical production and delivery data is a huge data set that was originally collected through the EAR. And we did not like go through and perform like a detailed QC of all that data. So it is likely, and there are known quality issues in some of these data. So what we've really focused on is making sure that data were well documented. And through making data open and public, we're hoping that that helps in some of the QC process.
Got it. Thanks, Ashley. A flag for the students, and I see someone just posted a resource too, so we'll be sure to document that. But just kind of considering color choices, especially because we're going to be making this dashboard public. The state definitely has some best recommendations around that, so we'll be sure to adhere to those. I saw a question about live connection got answered in the chat, so thanks for that. One other question that I think you just started to answer, Ashley, is how did we account for changes over the years in how these data have been reported and kind of the detail of the reporting? And then kind of for the students, did that affect your ability to combine multiple years of data? And I'll just say that this was definitely something that we talked a lot about over the course of the project, and I think are still kind of documenting best recommendations or workarounds for that. But maybe I'll turn it over to the students to answer that a bit more detailed. Yeah, just kind of how did you guys deal with, you know, your data gaps and combining data sets or kind of processing data sets when the reports, the shortage levels, for example, have changed how they've been reported over the years and things like that.
Yeah, I think at first, when we were first looking at the data, we would have really liked to have some overlap and compare, data sets with the same org ID and look at if, we could do any statistical analysis or anything. But we really found that, yeah, there's really no date overlap between most of them. And if there is any date overlap in the data sets, it's pretty minimal. So, and we understand like why it is like that, of course, especially with like the actual shortage, with it being standardized to a 0 to 6 thing instead of just like an open response. It definitely makes sense that the data looks like that, but it was something we definitely talked about a lot and would have liked to do more, but here we are.
No, that's part of it. I feel like that's, part of what we're trying to find out together too. So I think it's all super helpful. A kind of follow-up question is, and Ashley, you might know the answer to this too, but I think it's kind of hard to know overall is, were any of these missing data points kind of mandatory questions not being answered and thus kind of essential missing data? Or, do we have any idea if some of those were more optional questions in the self-reporting? But I don't know that we know that.
Yeah, I would assume if they were, I know like the urban water management plan and others have like a number of data validation when they're entering data. So if it was required, I imagine that we would have data there. So assuming it's some of these optional fields, but I haven't dug into like, are these data essential? And don't want to put the Bren team on the spot, but you did do a lot of work on the missing data. And if you had a sense of like, anything about the missing data, feel free to jump in.
Yeah, I think for the missing data, like one thing about it is that there's NAs in our CSV file, and some of it's probably most likely from just not submitting a value because we can probably assume it's 0, but that's one of the problems too, is that we don't want to make any assumptions about our data sets. But it's one thing to think about that, it might be like a 0 value that they just didn't, like, because since it's self-reported, right, they don't want to go through and enter zeros for all of their NA value or their 0 values. It's just a lot easier to keep it blank, which just turns into an NA when you convert it. But yeah, that's one of the things to think about for sure.
So zeros matter, everyone. Yeah. Any other questions? I know we're kind of getting close to the top of the hour. Thanks so much for the presentation, everyone. But any other questions for the team here before we close things out? See more resources.
A quick comment going back to, I think, Ted's question about let's see, like colorblind friendly palettes. I know for the visualizations that we showed in this in our PowerPoint, the problem that we had is that the graphs that we had, the two line or the line graphs, they are composed of like 14 variables. So I tried to get a color blind palette that had like 14 different colors, but that's definitely a like or not a problem, but it was definitely a hardship. So if any suggestions for how to make that better, I would definitely appreciate it.
Yeah. Well, oh, symbols and colors. Thanks, Laurel. Yeah. Well, if there's any other questions, please feel free to email us. We'll send out the presentation so that you have the emails of all these awesome students and presenters here, and you can get in touch with them directly. And yeah, just thanks so much, everyone. This project has been like a real gem to work with you all, and I feel like it's been going so great so far. So excited to see where it ends up. Yeah, just getting a lot of suggestions in the chat about line styles and things like that. So
Thanks, I appreciate it.
yeah. Cool. Well, thanks everyone. Yeah, we'll send out the recording soon. And yeah, please feel free to get in touch with the students or Ashley on any questions you have.